What a nice crowd. Good evening, everybody. How are you tonight? Good. Thank you for coming out on this crystal clear, beautiful night. We have a great talk in store for you tonight, and that's all I'm going to tell you. This warms my heart to be able to introduce Lonnie's better half. So Jan is going to do a beautiful introduction tonight and then turn the show over to Lonnie. So thanks, guys, for making the reservation and wearing your mask. And here's Jan.
Jan.
Good evening, everyone. In the far, far future, when the Milky Way and Andromeda galaxies, yes, he gave me a script to read, Andromeda galaxies collide, what Lonny Buinis would like people to remember for him was being the husband of Jan Buinis and not bothering her too much. Well, that ship has sailed. However, he has many other projects underway, like keeping on telling you good visitors what's up in the sky since UACNJ got started 26 years ago. He is honored to have the Lonny Buinis Observatory dedicated here in April 2016. Lonny has more respect for practical experience than book knowledge, but figures somebody expects to know why we should believe anything he says tonight. He holds degrees from Stevens Institute of Technology in Physics and Computer Science and is a member of the International Association of Astronomical Artists. Even so, he is perfectly comfortable if this evening you choose to ignore him, look through the telescopes here, ask questions, and see what's up in the sky for yourselves. Without further ado, my husband, Lonny Buinis.
Welcome, everybody. I'm glad to be here, and I'm glad that you made it here in this unusual situation. I'm going to try to project my voice. Please let me know if you can't hear me. I am on a microphone, so it does make things easier, because the last time I was here, most of the people who were here heard the crickets and not me. So I will not have to yell at the crickets tonight. Would it be okay to turn off the light so it's not in the eyes of the audience? Yeah, it was. I went out there and I saw, I was kind of blinded by the light. I've got a little light here. Oh, okay, thank you. Everybody see all right? Great. We're here to find out what's up in the September sky. This is something that I do each month. We used to do it only April through October, first Saturday of each of those months, because after October and before April, those months are just very cold up here. And it's very uncomfortable to go outside and look up in the sky and freeze your eyeballs. And you don't want to put your eyeball up against the telescope and have it frozen to the lens the way it happened in A Christmas Story, the Gene Shepard book and movie. It's not pleasant. So what I'm going to do is use my remote control and give you a little tour of what we expect to see when things get a little darker. All set? One of the things you're going to want to look for is this shape in the sky that looks sort of like a lid, a spout, and a handle of a teapot. Before we proceed any further, we're going to be seeing this information at the very end. And the most important thing to remember out of all this is whatever you do, ladies and gentlemen, please, when you go to look through the telescopes that the amateur astronomers have spent hours setting up, aligning to the sky, whatever you do, don't kick the tripod. Some of you might have heard that an asteroid passed close by the Earth on September 1st. This goes by the very attractive and easy to remember name 2011 ES4. Got it? 2011, after me. 2011. That's okay. So this asteroid has an orbit in the green area outside the orbit of E for the third planet. Very good, Earth. And before the fourth planet, starting with M, Mars. These Apollo asteroids, a family of them, never quite cross the orbit of Earth, but they come close. So they're in the family of close approaching asteroids that may or may not collide with Earth in the future. We're keeping an eye on them. This one is small, a little over 80 feet. Could do some damage if it hit. It was discovered coming close to Earth in 2011. They saw it for only 4 days that they were able to take accurate measurements, so the orbit wasn't that well established, and they weren't sure if it was going to collide with us in 2020. But 2020, that's so far away, who cares what oh, wait a minute. Oh, yeah. Yeah, it's now. In fact, the thing came by around September 1st, plus or minus 8 days. Expected to pass only 74,000 miles, which is within the orbit of some of our satellites. Pretty cool. The only problem is that I looked this up, and for the life of me, all I can find are articles about the asteroid coming in the future on September 1st. Now, any members of the audience know what today's date is? Yes, thank you, the 5th. So this is obviously the past, and I really don't know what happened. I looked it up online. I couldn't find anything. If any of you right now, I see you furiously, frantically searching your phones and tablets. Excellent. So if you have any information, let me know. I wondered what they meant in this last bit of information. No risk of an impact. The line of variation does not pass through where we'll be. Well, what is a line of variation? I never heard of that before. So I looked it up, and I found this reference, which is really funny, because not only is the title really sexy, Multiple Solutions for Asteroid Orbits, Computational Procedure and Applications, something you could read in the bathroom along with your news and never forget, right? And it was done by these people in a scientific paper. And so they explain it, but I think it's pretty funny. They're talking about a one-dimensional sampling of a six-dimensional orbital confidence region, and then they conclude by saying, following this typically curved weak direction or line of variation. So ladies and gentlemen, there you have it, clear as mud. Before we proceed any further, I do want to reassure you, young members of the audience, I have approved all of the following preview of the sky for all audiences, so there's no need to get up and run away or to cover your eyes. So if you want to see what's coming up in the sky, I recommend that you go to seesky.org. Now, I don't know if all of you can see my laser pointer all right. Can you see that? I have an old-fashioned pointer, which doubles as other functions. And so, whoops, getting a little ahead of myself. And so, seesky.org. Oh, we seem to have a crisis. Technical difficulties. But that's okay. Thank you. Go to seesky.org, and instead of looking or trying to remember where the astronomy calendar is with all the events, all you have to do is click on Explore the Sky, because that's why we're here, right? What's up in the sky? Look for the second entry, the reference guide, the astronomy reference guide. And then on the left, look for astronomical calendar. Right, so it's kind of fun to hunt and find this stuff on your own. seesky.org, do a little poking around. The astronomy reference calendar lets you look in the past and the future, as well as the present. Click on 2020, and you'll see all the events for the whole year. You can scroll down to the current month. That's what I did. I chopped out different pieces to show you date by date. So first we start with the full moon, September 2nd, in the past, a few days. Now, why is the full moon a lousy, scientific term, lousy time to look at the sky? Too bright, right. Its light interferes with the light of faint objects. We amateur astronomers like to look for things we call deep sky objects. And I'm going to explain what that is by showing you one later. The great thing about the full moon, which happens 12 times a year, did you know sometimes twice in a month? Twice in a month, if there's a full moon, what do we call that? It happens once in a blue moon. Has nothing to do with the color. Well, it can. Volcanic eruption, a big one. In the past, the moon has turned a blue color. But the common blue moon is when the moon happens twice in a month. Because a month averages 365 and a quarter divided by 12 over 30 days. Because 30 times 12 is only 360. There's 365 and a quarter days in a year. Which means that because the moon goes through its phases in 29 and a half days, it doesn't always go outside a month. You can fit 2 of them in a month if you hit it just right. And then the next month they'll have no full moons. Poor month. Got to feel sorry for it. The cool thing about the full moons is that they each have independent names. The corn moon this month, Native Americans early on realized this was the time to harvest corn. And so the full moon became the harvest moon, the corn moon, to harvest corn, because you could see to harvest even after the sun set. If you want to compute what time that exactly happened, all the times on csky.org are in universal time code, UTC, universal time being the time at the prime meridian running through London, England, way over here. In the 0 time zone, we are 1, 2, 3, 4, 5 zones westward using daylight savings time, only 4 zones Eastern Standard Time. We're in daylight savings time now. So to convert universal time to our time, subtract 5. What's 5:23 in the morning minus 5? Mathematicians in the audience, say it again. 5 minus 5 is? Yes, 0 is midnight. Just after midnight, 23 minutes, that was the full moon. Another attraction, Neptune. The planet Neptune, pardon me, is a giant planet. If I get too close, just yell. Can you hear me? The giant planet Neptune is the 4th of the giants, Jupiter, Saturn, Uranus, Neptune, so far away that it's 30 times the distance of the Earth from the Sun. To get a rough estimate, 93 million miles from Earth to Sun, round off to 100, multiply 100 by 30, and you get, audience participation is not punished, 30 times 100, 3,000 million miles, 3 billion miles. It's, in other words, as we say in science, it's pretty far away. Neptune and the Earth make a straight line with the Sun. It's called being in opposition, like opposite. Sun, Earth, Neptune. Neptune's as close as it's going to get to us. 30 minus 1 AU, astronomical unit. 30 minus 1 is 29 astronomical units, 2.9 billion miles. And I did see when I was a kid, I took my telescope, I found Neptune, small telescope with a lens about 2.4 inches, 60 millimeters, and it looked like a very tiny little round dot. Not like a star. No matter how much you blow up a star in a telescope, it's going to look like a point. The planets look like disks. I did see the disk of Neptune in a small telescope. And if I trip over the cord, you'll remind me, right?
Yes.
Good.
I'll let you know.
Thank you.
No problem.
Where is Neptune tonight? Well, unfortunately, we're not going to see it in the early September sky. It comes up later by the constellation Aquarius and Pisces the fishes. But if you do stay up late this time of the year, till about 1 in the morning, you will see not only the bright planets Jupiter and Saturn, but the red planet Mars. And right nearby is Neptune. Can you see it?
I don't see it.
No, you're not gonna see it. You need a telescope, right? And in a telescope, in a big telescope, it shows as a featureless bluish disk with a white equatorial cloudy band in the middle. And very faint rings are invisible in any telescope. They're dust rings left over by some of the moons orbiting Neptune. The only one that you can see in our telescopes is the big one, Triton. The rest are just too small. So good time to find the giant. September 17th, later in the month, we have a new moon. Why is that better than a full moon? Well, the new moon is when the moon's close to the sun, which is the source of light in the sky, right? And so it's not lit up. The sun is behind the moon. The moon and sun look the same size, right? That's why we have eclipses. But the neat thing is, a neat comparison is, the moon 250,000 miles away, the sun roughly 100 million, a quarter compared to 100. The sun is 400 times further away than the moon, but the moon is 400, not only is the moon 400 times smaller than the sun, but it's 400 times closer. So they look the same size, apparently. The sun is so big, you could put about 100 Earths across it, across the middle of the sun. So, what's great about the new moon, which happens at 11 universal time, minus 5 time zones, that's, what? Very shy people in the audience. I heard somebody mumble something like 6 through their mask, which, ma'am or sir, I can't see. You did very well through the mask. 6 is correct. That's 6 in the morning on September 17th. New moon. Now, why is the new moon so great? It's not old, like me. Yeah, I was born in the time, the Jurassic, no, I think it was the Triassic, came before the Jurassic, a few 100 million years ago. Why is the new moon so great? Well, it's great when you come to a place like Jenny Jump, UACNJ, which I pronounce UACNJ. Say after me, UACNJ. Excellent. Now you'll never forget that. UACNJ is the darkest observatory site in the state of New Jersey. And when the moon is new near the sun's in the daytime. The moon isn't in the night sky. It's dark. It's really dark. In fact, it's so dark you can see the Milky Way rising from the south straight up over the entire sky into the north. It's extraordinary. There's the moon. There's the sun when the moon is near new, a tiny thin crescent. You can simulate this in those free sky programs you can get for your phone. There's about a couple dozen. I downloaded Skyview, but it's only one of many, and it'll show you things like this. September 22nd is the equinox. Days are equal, day and night. If we were not on daylight savings time, the sun would rise at 6 in the morning, it would set at 6 at night, the day would be 12 hours long, the night would be 12 hours long. You see, audience participation doesn't hurt, right? The equinox happens at 13 minus 5, 8:30 in the morning. The sun is directly hitting the equator. So if we took the equator of Earth and expanded it out into space, it would look like this. The blue line. The path that the Earth goes around the sun is called the ecliptic path. And because the Earth is tilted as it goes around the sun by 23.4 degrees, the sun's path through the sky is tipped in an angle. And only twice a year does the sun cross our celestial equator. The vernal equinox, the autumnal equinox. Which one are we in, the vernal or autumnal? I can wait all night. What season of the year are we in? Right, so this is the autumnal equinox, and it happens this month on the 22nd. You can use programs like Skyview, an app, or you can use a computer program like Stellarium, free at stellarium.org, which is what I'm going to use now in order to show you the sky in a more lively way. No still pictures now, a free computer program. And let's take a look at Stellarium. You can install this program, download it, install it for free, stellarium.org. It is kind of like having a planisphere, which is a circular star map that you can adjust for the time of night or day and the time of year by month. We happen to sell them. This is my only advertisement. We sell them in our gift shop. You might want to take a look later. They're cheap. They're fun. Oh, what do you know? Great timing. And they help you learn the sky. That's how I learned everything that I'm telling you tonight. Stellarium is kind of like having a fun live planisphere. You can move it around in direction. You can face north like this. And you can learn the constellations by using the scientific term cheating. You can turn on the lines that are used to draw between the stars by astronomical mappers, right? We don't have these in the sky. You can shrink everything down so it fits on a flat piece of paper, but I have to warn you, in the real sky, the star patterns we call constellations are enormous. And in fact, for the great square that I'm going to show you when I finish, you actually have to turn your head to see the whole thing. For those of you who can turn all the way around 180, look over the trees, you'll see two bright planets, Jupiter and Saturn, which are going to feature a little bit later. If you look in the north, though, that's this way. You see the Big Dipper? No, you can't. The house is in the way. But when you do go out later on, when I finish, look for the Big Dipper low in the sky. It is not one of the official constellations decided on in 1930 by the International Astronomical Union. It is a star picture called an asterism. An asterism is just a pattern of 7 stars. Let me see if I can turn that off. 1, 2, 3, 4, 5, 6, 7. And actually, if you look very closely in the bend of the handle, you'll see that there's another one, 8 stars in the Big Dipper. If you have sharp eyesight, see if you can see the double star Mizar and Alcor. Or ask the astronomers here to show you this double through their telescope. Just remember, don't kick the tripod. Thank you. The Big Dipper is part of Ursa Major. Yeah, I can cheat in Stellarium. I can put up pictures to help you. But, of course, we know that there are no such pictures in the sky, not even lines. Head the claws of the Great Bear beneath the horizon this time of year. We can find the Big Dipper's handle arcing in a giant arc to the bright star Arcturus. When you click on something in Stellarium, it gives you some identifying information. Arcturus is the 4th brightest star in the night sky, the 5th brightest star in the sky. What's the brightest? Sun. Very good. Can't fool some of the members of the audience. I'm trying. My wife says I'm very trying, but don't tell her. Don't tell her I told you. Arcturus, orange-colored star. Your naked eye that you got when you were born is a great astronomical instrument because it can see star colors. It can see star temperatures. This is a cool star compared to the sun. Cool. Only a few hundred degrees, maybe 1,000. The sun, 5,000 Kelvin, 10,000 Fahrenheit. Other stars, 20, 30,000. Blue stars. Your eye can see star temperatures. It's kind of like a gas flame. These are the constellations that are disappearing in the west. Boötes the herdsman, who looks exactly like a herdsman. But if you look in the north, you can orient yourself to constellations that never rise or set, just spin around in a giant circle, counterclockwise, around the North Pole. And if you want to find the North Pole, the Earth spins like a top. It has an axis and a pole facing that way at any jump, north. You would follow the Big Dipper's pointer stars 5 times their distance apart. 1, 2, 3, 4, 5, and you would miss the North Star because the Earth's North Pole is about here. It's not directly where the North Star is. However, it's nice that we have a bright star nearby. People who live in Australia, South America, Africa, South Africa do not have a South Star. They have a cross that points to the approximate position. We're pretty lucky. Things change, though, because the Earth, remember I said it spins like a top. It has an axis. Have you ever watched the top run out of juice? It precesses. That's called precession. It wobbles. The Earth wobbles also from the pull of the Sun and Jupiter and some of the other planets. The wobble is very slow. If you go to Switzerland, there's a clock with a movement that does this every 24,772 years. So watch that gear. Those very clever Swiss have some great gearing in their clock that shows precession. 3,000 years ago, the constellation Draco the Dragon had our pole star. This one, Thuban, Alpha Draconis, brightest star in the Dragon. And in 10,000 years, it will be Vega, bright star of the summer. So now we've seen the Big Dipper, the Little Dipper with the North Star, Ursa Minor, the Dragon, and finally, the Queen and King, who look exactly like, no? Cheat a little bit. Cassiopeia and Cepheus. Cassiopeia is a unique W shape. And if you were to travel to the nearest star to the Sun, some of you may have heard of it, it's the brightest star in the Centaur, so it's called Alpha Centauri. Alpha Centauri. Right here, you would see a bright yellow star, one of the brightest in the sky, and that would be our Sun, looking like any other star. The husband of Cassiopeia, Cepheus nearby. These 5 constellations never rise or set. They spin round and round in endless circles, which through time-lapse we could observe in Stellarium, because in Stellarium you have a time machine that can spin you right into the daytime. Can you see stars in the daytime? Yeah, one, you can see the sun, but that's the only one. I can reset my time back again. So we're looking at September 5th, 8 in the morning, and I can go forward in time, 24-hour time. 21 is 9 p.m. At 9, 10, and 15 p.m., we'll let the time run in real time now, we're back to the way our sky looked before. However, the most interesting part of the sky is not in the north. If you live in a place where you're lucky enough to see some of the south sky, that's the place where the path of the sun travels, and the moon, and the planets, because they all follow the sun in a flat plane, kind of like a giant dinner plate, right, with the peas, not the carrots, the peas spinning around the center. The solar system is pretty flat. Most planets lie in a plane close to the Earth's, not Mercury, a little bit tipped, not Pluto, quite a bit tipped, and not the comets and the dwarf planets, all different directions. But the major planets are all in a flat plane, and so they pass through special signs, special constellations, which you probably have heard of. Anyone? You've heard of the zodiac, right? The zodiac, the constellations through which the planets pass. Very important. Now, if there are any piano players in the audience, piano players? None? Anybody ever count the keys on a piano? I was a geek as a kid. Not now. My wife will tell you I'm really cool. But I did count the keys on the piano, and there are the same as the number of constellations in the sky. 88, right. There are only 13 that you need to worry about that the planets pass through. Yes, you heard me right, not 12. Now 13, because remember I told you the Earth has wobbled? In 3,000 years, it's wobbled itself so that there are no longer 12 constellations through which the planets, sun and moon pass. And I'm going to show you the 13th sign of the zodiac. And it's right here. A big horseshoe shape carrying serpens caput and serpens cauda. Serpens caput, the head of the snake or serpent, the tail of the serpent cauda. Ophiuchus, the serpent bearer, is low in the sky. It's a huge constellation, very big. To see it, you'll have to turn your head like this. And it is a place where the planets will pass. And so astrologers are now wrong not to include this as one of the signs of the zodiac. If you look low in the sky, you'll see the famous one. There's only about 2 constellations that I think in the whole sky resemble what they're supposed to be. One is the winter Orion the Hunter, 3 stars in the belt. This one, can you recognize it? Stinger on the end of the tail, claws in front. You would not want to wake up in the desert and find this creature seeking warmth in your boots. Scorpion. And right next to it, the teapot that I showed you earlier. Let's take a closer look at the teapot. For here, right above the spout, where you see the steam of the Milky Way rising, like steam out of a teapot all summer long, we find a multi-million mass black hole. The biggest black hole in the galaxy is at its very center. It's devouring stars, dust, and gas as we speak. And how do we know this? Because for the first time in history, within the last 10 years, astronomers have watched this thing gulping down whole stars. It's very hungry, right? A black hole is such intense gravity that not even the fastest thing in the universe can escape it. Not even light. Light bends around, enters the black hole, and never leaves. This thing weighs as much as millions of suns. Are we in any danger? No. This thing is about 30,000 light years away. So do not worry. In 3 billion years, our galaxy will merge with Andromeda, which Jan mentioned at the beginning, and the 2 black holes at their centers will also merge to become a bigger black hole. So if you want to find the black hole, and you look right here, can you see it? Where the arrow is, can you see it? No. Why? Because it's black. Right. You see how science works? Yeah, you cannot see a black hole. You detect it by its presence, its influence on everything else. As gas and dust heats up, as stars fall in, the gas heats to such an extreme that it gives off X-rays, and X-ray telescopes can see it. Look for the teapot, Sagittarius the Archer. Sagittarius the Archer is a centaur, half man, half horse. We're going to look for his arrowhead in the sky as well. This is the place to look for the bright planets Jupiter and Saturn this time of year. And it's this time, don't miss it. By next month, when you come for What's Up in the October Sky, as I hope you will find it very difficult because those planets will be low in the sky, setting earlier and earlier as time goes on. Every month, there's something different to see because as the Earth moves in its orbit around the sun, and we look at night in one direction, we're looking in different directions. So What's Up in the October Sky will have some things that are a little bit different. Look here carefully at here in Jenny Jump, above the spouts, above the spout of the teapot, and you will find a fuzzy cloud. It looks like a fuzzy cloud. In large telescopes, there is a lagoon of dust running down the middle. And so astronomers have given us the beautiful name, the Lagoon Nebula. A nebula is a gas cloud in space made of the most abundant substance in the universe, hot air. Oh, wait, no. That's politicians. I'm thinking of the wrong thing. This is hydrogen gas, the stuff that makes up stars, the most abundant stuff there is. And someday it will collapse to form stars. How do we know that? It's giving off red light, reddish light. It's that signature hydrogen. We know because we've seen stars being born in nebulae like this. Very exciting, because here at Jenny Jump, if you look over there on a dark night, you can see the Lagoon Nebula without a telescope, without binoculars. You can use the naked eye. And all of you have them. So go out and use them. That's why we're here. We're here to encourage you to ask a lot of questions. There's no such thing as a stupid question here at UACNJ or UACNJ. Because if I can use a stupid term like UACNJ, you know there's no stupid questions. Ask the astronomers everything. Ask them about what they're showing you. You can see this with the naked eye. Very exciting. The first time I did that here, I was extremely excited. Right nearby, there's another one, another nebula, famous. It's called the Trifid, or Trifid, because it has dark lanes of dust, splitting the nebula into three parts, as seen from Earth. If you were to travel here, it would be like going through an invisible fog. You would hardly notice anything, if anything. Why does this nebula have two colors, blue and red? Hydrogen gas glows red. Starlight reflects off the gas, the light of blue young stars. And why is everything drifting slowly? When you look through a telescope that does not have a clock drive on it, you're going to see things drift. And astronomers will ask you to step away so they can put the image back again, because something is moving. The whole sky seems to move from east to west. Why? Because the Earth is rotating this way, right? So we need to keep up with that, and a lot of the telescopes here have clock drives that counter that motion. So look for beautiful nebulas, gas clouds this time of year. There's a lot of them in this area of the sky because we're looking far into space in the direction of the center of our galaxy. If you want to look a little bit over to the left, you'll see an embarrassing sign. To me, it looks like a bikini bottom or a big smile. It's my sign. And since my wife will tell you I'm an old goat, it's the sea goat. So I will never admit that this is my sign. In fact, Isaac Asimov, famous author and scientist, wrote over 1,000 books, maybe 2. Science fiction and science. Once was invited to debate an astrologer, and he refused because he found out his sign was the goat. Forget it, he said. That's supposed to be my sign, but because the Earth has wobbled in 3,000 years, my sun sign, the sign where when I was born, the sun was supposed to be there, it was actually here in Sagittarius. Everything is shifted by one whole sign in 3,000 years. So not only do astrologers not account for the shift, but they do not account for Ophiuchus. Next time you see an astrologer, complain a little bit. Look up higher in the sky, higher. Tilt your head way up, and you will find a letter H, spelling out Hercules, famous hero. Hercules is typically drawn on star charts as upside down. I don't know why, poor guy, but there's no up and down in space, right? So that's okay. You can use Hercules to help you find a deep sky object. Remember I mentioned that before? Deep sky objects lie thousands of light years from us, but that is relatively close in the Milky Way galaxy. The Milky Way is about 100,000 light years across, the visible portion. The part with dark matter is even bigger. And there's about 1 trillion stars in it, 1,000 billion. to find a nearby, relatively nearby deep sky object, this one about 25,000 light years away, all you need is a pair of binoculars and the keystone, this shape, shaped like the keystone in an arch. Look right here, and you will find a fuzzy blob. This is called, well, let's see, what would you call it? It's a compact globe of stars that cluster together, very close. There's a lot of these. There are thousands of these that circle the Milky Way galaxy in all directions. They formed first. They're the earliest clusters of stars. And because of their globe shape, astronomers, you guessed it, have a scientific name. Anyone? Who said that? You win. What do you win? Let's see. You win dark adaptation, so you can look at the sky later. Globular cluster is correct. This one is the most famous globular cluster visible from New Jersey because it's the most easily observed from New Jersey. There's a bigger one in Centaurus, but that's very low in the sky, and the trees get in the way. In a small telescope, it looks like a foggy globe. In a bigger telescope, you'll thousands. In the Hubble Space Telescope, 500,000 stars. If you lived on a planet orbiting one of these, your night sky would look like street lights. You might never know that there were nebulas and faint objects. This is M number 13, named for Messier, French astronomer, who made a catalog of objects that got in his way when he was looking for comets. He said, I'm going to throw out all this junk that I found that's getting in the way. It's over 100 objects. They're used as a challenge by our amateurs here, our astronomers, to see if they can find all of them in one night. They stay up all night. Sounds like fun, right? You would do this. Stay up all night, search for all 104 Messier objects, including M13. And Charles Messier threw them all away. He was looking for comets. Why do we remember Messier today? Anybody? Take a wild guess. The Messier catalog of all the stuff that his mother said, don't throw this away. It's like your mother always said, it's going to be useful later. M13, look for it. Ask the amateur astronomers to show you what it looks like in different telescopes. You can get different views tonight from different amateur astronomers' instruments. Look through a small telescope. Look through a big one. It's an interesting difference. And there's different skills involved. It can be easier to use a small one. It can be easier to use low magnification rather than high. Hercules, the crown, Corona Borealis, northern crown. There is a Corona Australis. What's that mean? Anyone? Corona Australis? Southern crown. Yep, there is another one. Underneath Orion in the winter. When I do what's up in the winter sky, we can talk about that one. Look up high in the summer sky for 3 bright stars. Deneb, Vega, Altair. They form a giant triangle in the sky. You see it in the summer, so it's called the, I'm going to let the audience take over. It's called the Summer Triangle. You guys are brilliant. You're getting the hang of the scientific terminology. So the Summer Triangle is very easy. It's very big. And 2 of the stars in it were involved in science fiction movies and stories. Right? If you look at Vega, for instance, this is going to be our pole star. Yep, really soon. Goodbye, Polaris, North Star. This is going to be our pole star. Whoops. In about 10,000 years. Stick around. We'll have a nice bright North Pole star. It's in Lyra the Lyre, little tiny harp inside Lyra. Right down here, there's a very faint planetary nebula right there. You see that little ring? All right, for you guys planning to ask your girlfriends the big question, this is the Engagement Ring Nebula. It's actually called the Ring Nebula. It's a sphere, but it looks like a bubble because the thickest part of the sphere is on the edges. It's like when you look through a Christmas ornament, the edges are hard to see through. The center is more clear. The exploded star is in the middle, now a dwarf star. That's a star that's puffed off its outer atmosphere, its surface, to become a beautiful planetary nebula, so called because early planet hunters mistook them for planets. They're round like a planet. This is one of the most famous, but it's also small and faint and a difficult object. Good to see in one of our bigger telescopes. And it is not this colorful. This is a long exposure photo. Most things, I have to warn you, when you look at deep sky objects, we have a scientific term for this. Most of these deep sky objects, when you look through our telescopes, they're going to look, now take note, write this down, boring. Boring. But it's exciting to know what they are. So ask questions. Ask the amateur astronomers, what am I looking at? What is it? And they'll explain it. Look for it in Lyra the Lyre, an ancient harp. Ancient harp. One of the summer triangle constellations. The other is a beautiful swan, Cygnus the swan, looking like a cross. And here, one of my favorite stars in the sky. In Stellarium, you can center an object by hitting the space bar. You can zoom in with your scroll wheel to see the famous double star Albireo. Now, not here, not on the computer, but in the real sky, Albireo is one of the most striking objects you could possibly see. One star is golden in color, the other a beautiful cerulean blue. And the contrast is striking. These two orbit one another over hundreds of years. A true double star, not like Mizar and Alcor. These actually orbit one another very slowly. It's a beautiful cosmic dance. The colors are breathtaking in a telescope. They look like little points, not like disks. Points. Remember, even the biggest telescopes cannot see the disks of stars. They're too far away. Albireo, the head of Cygnus. And finally, I forgot to mention, Vega is in a science fiction story. This one, Vega, in the novel by Carl Sagan, Contact. We have Deneb, not in any story. And we have Altair in Aquila the Eagle. This is Altair 16 light years away. Aquila the Eagle. And that was in the movie Forbidden Planet, 1956. Classic science fiction. Don't miss it. Summer Triangle. And I'm going to wrap things up with a look inside constellation, an asterism. That's some of the summer sky. And if you look over, not in the south, but to the left, just go outside and look for the big letter E, right? Boy, a lot of gullible people in the audience. I don't know. Look for it. Don't look for the letter E. Look east, facing south. East is on your left, west is on your right. Look for a giant square of stars. You'll never guess what they call this. The Great Square of Pegasus, the horse. Pegasus is a huge constellation. I'm going to shrink it so we can see the whole thing. The head is upside down. They cut off the body and made Andromeda the princess. Andromeda, Perseus, Cassiopeia, Cetus the monster, Medusa, they're all up there in the sky. They're all in the story of Perseus and Andromeda. The movie Clash of the Titans, the remake Clash of the Titans, right? You've got no excuse if you haven't read it. It's been in the library 3,000 years. Check it out. You can find the most distant thing you can possibly see in the whole universe by finding this star in Pegasus. Count 2 stars over, 2 stars up. 1, 2 over, 2 up, and look for a fuzzy blob between the arms of a little letter Y. This is in the Guinness Book of World Records. Guinness Book of World Records, the most distant thing that you can see with the unaided eye is the nearest large galaxy to us, the Andromeda Galaxy. It's bigger than ours. We have 1 trillion stars. this has even more. It has 2 little satellite galaxies. It actually has a couple dozen satellite galaxies, as do we. But we have 2 big ones that some of you who have been lucky enough to travel south of the equator may have seen. Anybody ever see the clouds of Magellan in the sky? Some of you, if you travel south, look for them. You can't miss them in a dark sky. They look like little pieces of the Milky Way that broke off. They are satellite galaxies that collided with us millions of years ago and on their way out and back again for another collision. It takes a long time to do a celestial dance in the sky. Very slow. Andromeda's got 2 that you can see in small telescopes as well. Little galaxies, mini. Over 2 million light years away, we're looking at this thing as it looked about 2.5 million years ago. But that's nothing in the life of a galaxy. Galaxies live for thousands of millions of years, billions. And so 2.5, that's like a few minutes in your lifetime. These are the stars of late summer, early autumn, October. So don't miss, advertisement, what's up in the October sky. You can do this yourselves in Stellarium. I'm going to quit and wrap up my talk with a few more things before we look at the real thing. So try that for yourselves. A very clever artist, Mary Ellen Croteau, took old milk caps, bottle caps, and made this montage. Isn't this cool? Recap. Let's do a recap. Planets. Look for the planet Jupiter tonight. I see it's up above the trees. We're going to take a look at it in just a few minutes when I finish through some telescopes. There are some spectacular photographs taken by amateur astronomers now. Really incredible. Christopher Goh, Damian Peach, and others. Saturn. Both of these planets are in opposition with Earth, meaning they're at their closest and brightest. And they are spectacular. Saturn's rings are open now. You can see the gap in the rings. Even Mars. If you stay up late this time of year, about 1 in the morning, Mars rises in the east, and it'll make a line with the other planets. And by the end of the month, a 4th object will join them. I'll show you that in a minute. But first, a recap. Looking south tonight, 9 o'clock, Jupiter, Saturn, and note the position of the Milky Way and Jupiter compared to the S and south. Now watch what happens when I jump forward to September 15th, middle of the month. Tonight, 15th. Tonight, 10 days later. Did you see that jump? If you pick the same time to look every night, the sky is going to change. Over a month, it will change by 1 whole zodiac sign. That's why we urge you to come back and learn about the sky. Look for the summer triangle. Look for Jupiter, Saturn, the teapot, the Milky Way, and the early sign of autumn, Pegasus. If you look high in the sky, summer triangle, Hercules with M13 and the crown. Look low, the center of the Milky Way. You might be privileged to see the Lagoon Nebula with the naked eye. Look for Jupiter, Saturn, the Moon, and Mars at the end of the month on the 30th. The Moon makes a nice quartet as it moves right along this path over the course of several days, ruining the sky if you want to see deep sky objects. Not a good time to do it when the moon's up like that. And finally, a question to think about. How did Pluto's moons form? This is in the news recently. I always like to put just one little bit of news with all of my What's Up talks. How did they form? Well, there's a new study that says it may have been a collision with the giant moon Charon, which is a big fraction of the size of Pluto. The two are actually like a double planet. Pluto and Charon orbit a point outside of Pluto. Unlike the Earth and Moon, the Moon and Earth orbit a common center inside the Earth, but not in the middle of the Earth. So the Earth and Moon are really a sort of double planet. Pluto and Charon are a true multiple planet. And many dwarf planets are like this. See, I haven't tripped yet. Just wait. Wait for the comedic action later on. Anybody have a banana peel? The tiny moon, Styx, Nix, Kerberos, and Hydra, may have formed in a collision. This is the latest supercomputer study. Supercomputers have become so powerful that they can simulate what happened in the early solar system. We live in very exciting times. This laptop is a supercomputer compared to the ones I started with many years ago. It's the equivalent of a room full of ones that I started with years ago. Styx, Nix, Kerberos, and Hydra, Charon, and Pluto are all marked with this eye impactor in the early solar system that may have hit Charon with such force that it scattered the debris into a stable zone gravitationally. Styx, Nix, Kerberos, and Hydra, tiny little moons. We didn't even know about them until recently. Pluto is a multi-moon system, and many dwarf planets are like this. The one that was found by the space probe that photographed Pluto, it went on another 1 billion miles to find Arrokoth, a double asteroid. Two asteroidal bodies came together gradually and fused very slowly over eons. Weird. In other words, to use a scientific term, the outer solar system is weird. I'm going to leave you with some homework. Repeat after me. UACNJ. Yay! That's the United Astronomy Clubs in New Jersey. You can still read print magazines, Sky and Telescope Astronomy, written for lay persons such as myself. I am not a professional astronomer, but I've studied it for many decades. You can get started too. It is fun. It's mind expanding. Programs, free, Stellarium, Celestia. Celestia lets you fly through space, through the solar system. You can see what an eclipse of the sun looks like from the moon as the Earth eclipses the sun. You can go see what Saturn looks like from one of its moons. And finally, I belong to an international organization of space artists. We don't call ourselves astronomical artists because that's too, well, how many astronomical, that's many syllables. Astronomical, that's 5 syllables, that's ridiculous. Space art. I do space art and space animation, and you can find me on the IAAA website or on my own site where there's a picture of me and my wife at astronomyinmotion.com. And before we go, I said I wouldn't give you any more advertisements. I lied. I've written a book with interactive 3-dimensional virtual reality models of planets you can spin with your fingers on any phone, laptop, or with a mouse on a computer. And you can find this space history mystery solved everywhere. Check it out. So before you go, I'm going to ask you to be careful. Don't kick any tripods. Our astronomers don't bite. They won't kick back, but they will cry. And the worst thing to see is an astronomer crying because the tears interfere. They get in the way. You can't see anything. The tears go onto the lens, the eyepiece. It's a mess. It takes 15 minutes to clean. Believe me, you don't want to see an astronomer cry. It's very sad. So I hope you enjoy yourselves here at Jenny Jump, at UACNJ, at United Astronomy Clubs of New Jersey. And you've been a terrific audience. I'm going to stick around for questions. Thank you very much. Thank you.
All right. Thank you, Lonny, for our presentation. While I'm waiting to see if there are any last-minute questions from our online audience, are there any questions from our audience here?
They know everything.
I hear crickets, literally. All right. So, since we don't have any questions, we do have some things to note. We do have the porta potty to my right, your left. Out there, we do have a couple of telescopes. I think it's 2, right?
Yes.
All right. They just confirmed it's 2 telescopes set up with projector screens projecting what they're viewing. Because unfortunately, with COVID, we can't really have you viewing through the eyepiece without destroying the objective with the constant sanitation. So we do have what's actually through the scope projected onto a screen for you. When you are leaving, please use your headlights. It hurts to get run over by a car, and we'd like to avoid that. Don't ask me how I know. And with that, I do have a gift shop right behind me through this store. We do ask that one person, or if you have younger children, you can come in with your younger children. We want to just keep social distancing to, prevent any possible spread. And with that, thank you, Lonny, for our presentation. Thank you guys. Careful there.